Hi students, welcome to Bioline Homeschool. I am your Amrita Miss. Today we are going to study nucleophilic substitution reactions SN1 SN2 reaction mechanism under chapter haloalkanes and haloarenes. It is one of the very important topic for your board examination. Definitely you will get some questions from this part. So first of all, what do you mean by a nucleophile? Nucleus loving species are called what? Nucleophiles. So definitely they will be negatively charged. Correct? So nucleophiles are nucleus loving species, so they will get attracted towards the positive charge. So they are having negative charge. What do you mean by substitution? We are replacing one atom with another atom. That's called a substitution. So here one nucleophile is replacing the halogen atoms which is present in the haloalkanes. So that's what nucleophilic substitution reaction. So let me explain that. We will take a typical haloalkane. You know the structure of a haloalkanes, right? See, I'll take a typical haloalkane. I'll take a tertiary haloalkanes. See. So this is a tertiary haloalkanes, correct? So we know that these halogen atoms are more electronegative when compared with this carbon atom. So what will happen? This halogen will attract this shared pair of electrons towards its side. So this halogen will get a partial negative charge and this carbon will get a partial positive charge. Now what we can say? We can say this bond is a polar bond. Now this bond is a polar bond. Suppose if we are adding a nucleophile, another nucleophile in substitution reaction, what is happening? This halogen atom, it is replaced with this particular nucleophile, new nucleophile. So what you will get the product? We will get a product like this, with new nucleophile. So this is actually nucleophilic substitution reaction. So here what is happening? This nucleophile, if it is approaching towards a haloalkane, it will get attached here by replacing the halogen atom. So we are getting a product like this. So this is called nucleophilic substitution reaction. So this process actually happening in two ways. Therefore, we have two type of mechanisms, that is SN1 and SN2 mechanism. What do you mean by SN1 and SN2? S stands for substitution. N stands for nucleophilic. So S stands for substitution. N stands for nucleophilic. And what about these 2 and 1? This is actually indicates the reaction mechanism, the reaction kinetics, whether it is zero order, whether it is first order or second order. So here SN2, it is actually second order, that is bimolecular 2, okay, and 1 indicates that is unimolecular reaction. So therefore overall nucleophilic substitution are of two types, SN1 and SN2 reaction mechanism. Now we will discuss one by one. Coming to the substitution nucleophilic unimolecular reaction. It is actually a two-step process. It is a two-step process. So in the step number 1, it is carbocation formation. Step number 1 is what? Carbocation formation. Carbocation formation. So I'll take a typical haloalkane. See here, carbon. I'll take a tertiary haloalkane, or here halogen atom X is there. Then I'm adding a nucleophile here, okay, a nucleophile with a negative charge in the presence of a polar protic solvent. So these polar protic solvents, it may be alcohol, polar protic solvents, it may be alcohol, water, alcohol or acetic acid, okay. So under the presence of polar protic solvents, what is happening? So we know that this bond, okay, this is partial negative charge here, this is actually partial positive charge, there is a polarity difference here, correct? So what will happen? First, this bond will get broken, okay, this is the first step. So what we will get? R, C, R, R, and then here a positive charge. So these species are called what? Carbocation. So these species are called carbocation. Clear? Plus the remaining X minus. So why we are adding polar protic solvents? In order to solvate this particular X minus nucleophile. Why? Because otherwise it will return back, okay, it will go back and it attack again the carbocation. In order to prevent that, we are adding polar protic solvents. So now second step number 2 is the attachment of the nucleophile. So nucleophile will get attached. Nucleophile attachment. Nucleophile attachment. So here what is happening? See here the carbocation, towards the carbocation the new nucleophile will get attracted and it will get attached here. So there are two possibility of attack. Okay, so it can be attached. See, I'll write it here. C R plus nucleophile. Okay, so this nucleophile can be attacked through front side, or another possibility it can attack through back side. So two possibility, that is front attack or back attack. Front attack or back attack. Okay, suppose if it is attaching front side, C, the nucleophile get attached here, here R, and this is the product. Suppose if it is attacked at the rarer side, that is back side, so what is the product? Carbon here, sorry, here not. So this is carbon here, and then next R here, R here, this is the nucleophile R here. Now the nucleophile get attached here. So there are two possibility. If it is front attack, what we can say, the exact structure will be maintained. It is called a retention. It is called a retention. But if through backside, if the nucleophile is getting attacked, what we can say, the structure is entirely inverted. Correct? So that is called inversion. So in the case of SN1 mechanism, retention and inversion is possible because it can attack through front side or rear side. Okay, so if equimolar mixture of these two we are getting after the reaction, so that mixture is called a racemic mixture. It is called a racemic mixture. So more information related with the racemic mixture we will talk later under stereochemistry. So this is called a racemic mixture. So in SN1 mechanism, two possibility, nucleophile can attack through the front side or through the back side. If it is through the front side, that structure will be maintained, that's called retention. If it is attacking through the back side, the entire structure will get inverted, that is called inversion. Hope it's that clear. And here another information you have to remember, it is a slow step process. This is a slow step process and this is the rate determining step here. And the second step, that is the attachment of the nucleophile, it is the fastest step. This is the fast step. Hope it's that clear. So we'll move to the second one, substitution bimolecular reaction, that is SN2 reaction mechanism. We will take a nucleophile here. I am taking a primary haloalkane. See here, carbon, hydrogen, R group here, hydrogen, and here one halogen atom is there. Now I am adding a strong nucleophile. See, remember here we are adding a strong nucleophile. So already we know that there is a polarity difference here. See, in partial negative charge, partial positive charge. Since there is already a halogen atom here, this nucleophile will not come and attach through the front side in which one? SN2 mechanism, because there is a negative charge repulsive force will be there. Therefore, if we are adding a strong nucleophile, it will go and attack through the back side. So there is always a preference of rarer side in SN2 mechanism, and this is the fastest step and this is the rate determining step here. So what is the product we are getting? We are getting C, hydrogen, now R. Now here we are getting the new nucleophile is getting attached here. Now this bond also a little bit gets broken, and here hydrogen atom. So we are getting an intermediate product. This is intermediate product. At a time we are having two nucleophile. That's why it's called substitution by molecular reaction. Okay, now of course this cannot survive further, that bond will get broken, and we will get a product RCH. The nucleophile will get attached here, nucleophile, and then hydrogen. So through SN2 mechanism there is always inversion. Okay, there is always inversion. There is no retention here. Since we are adding a strong nucleophile, it cannot attack through the front side. It will always prefer towards the back side attack. So the structure will be inverted. Okay, so if you are giving a comparative view, SN1 it is a two-step process, SN2 is a one-step process. And SN1 carbocation formation, SN2 there is no carbocation formation. And the structure, there is a possibility of retention and inversion in the case of SN1, but only inversion structure in the case of SN2. Hope it's that clear. Okay, now we'll move. So this is same thing, there is a comparison. I already told you first step it is the carbocation formation. So it is a slow step process. Then next it is the fastest step process. Here both possibility, this is retention, this is actually inversion of the figure. We are getting a racemic mixture in the case of SN1. But in SN2 what happened? Inversion of the configuration, and this is here we are getting an inverted product. So SN1, SN2. Okay, coming to the order of the SN1 mechanism. See, the order is SN2 order. Okay, what is the SN2 order here? SN2 order. Tertiary will be more, then secondary, then, sorry, this is not SN1. This is SN1. So tertiary, secondary, and then primary. Tertiary, secondary, and then primary halide, and then CH3X. This is the SN1 order. What about SN2 order? SN2 order, it is like this: CH3X, and then it is primary, then secondary, and then tertiary. So here usually you will get some questions. Why tertiary is not preferring SN2? Why tertiary is not preferring SN2? Because see, in the case of methyl halide, that is CH3X, what happened? All our substituents are hydrogen atom. All are hydrogen atom. So it's a very small atom. So if a nucleophile is approaching through the backside, the attacking is very easy. But in the case of tertiary, see here tertiary, all are bulky groups. All are bulky groups. So through the back attack, it is little bit difficult. Correct? So the presence of bulky groups all near the carbon atom will hinder the approaching nucleophile. That is the reason, as the number of alkyl groups increases, what happened? The reactivity is actually decreasing. Therefore, SN1 is preferring tertiary, but SN2 is preferring, it's not preferring tertiary, it is preferring methyl halides first, then followed by primary, secondary, and then tertiary. So this order is very, very important. Definitely with regarding some indirect questions you can expect from this part. Okay, now tell me what about this one, whether it is SN2 or SN1? Yes, of course it is SN2 reaction order, correct? So this is methyl group, then primary, and then we are having secondary, and then tertiary. So SN2 tertiary reactions. Now suppose in the case of halide leaving groups, okay, so this also very important. Fluorides are the poorest leaving groups. Poorest leaving groups, it is fluoride. So see the fluorides, then chlorides, then Br and iodine, because iodine is a heavy atom, size is very big, so it can leave easily. So that's the reason iodides are the best leaving groups, but fluorides are the least leaving groups. So this order also you should remember. Now coming to what kind of question you can expect from this part. Definitely some question regarding definitions, give reason type questions, difference between SN1 and SN2 reactions, and identifying chiral atom, that is something very important, and then identifying the preference toward SN1 and SN2. To the definition part. What do you mean by chirality of a compound? Give an example. A chiral object which has no plane of symmetry is called a chiral carbon. Okay, see, let me explain. See, we know the valency of carbon, right? What is the valency? 4 valency, 1, 2, 3, here 4 valency. Suppose here I am attaching hydrogen, here attaching OH group, here one alkyl group CH3, here C2H5 I am attaching. See, the 4 valency, 4 substituents are entirely different atoms, correct? So we can say that if 4 atoms are of different types, that carbons are called what? Chiral carbon. See here, this is different, these 4 atoms are different. So this is, we can say this carbon, it is a chiral carbon. This is a chiral carbon. So if I am taking a mirror images of this, C carbon, here C2H5, hydrogen, H, here CH3. Whether it is superimposible to each other? No, they are non-superimposible to each other. That's why that carbon is a chiral compound. Therefore, we can say that a chiral object is not superimposible on its mirror images. It is a non-superimposible to its mirror images. Coming to the next question, out of these 2 compounds, which one is more reactive towards SN1 and Y? See, let me explain the first structure. See here, C, whether it is tertiary or secondary, it is a tertiary. How you will identify tertiary? Because the carbon atom which is attached with the halogen atom, if it is attached with the 3 other alkyl groups, correct? This is one alkyl group, this is another alkyl group, this is another alkyl group. So this is a tertiary structure, bromine here attached. Another is also a tertiary structure. So on the basis of the primary, secondary or tertiary, we cannot differentiate this particular question, correct? But what is the difference here? The attached halogen atom is different. They are of different type. So I already told you the reactive order. Fluorine is less, then chlorine, bromine, and this is the leaving group reactivity. So halogen atom, iodine is very heavier and it is the best leaving group. So this SN1 will be preferring which one? This particular compound will be preferring more towards SN1 reaction. Hope it's that clear. Okay, now coming to the next question, racemization occurs in SN2, SN1, neither SN2 nor SN1 reaction, SN2 reaction as well as SN1 reaction. So racemization, I already told SN1 reaction, only in SN1 reaction racemization is happening. Okay, so both backside and front side attack is possible. So it will form both retention and inversion is possible in the case of SN1. Therefore, racemization is happening in the case of SN1 reaction. Now next question, which alkyl halide from the following pair would you expect to react more rapidly by a SN2 reaction mechanism? So they are asking about SN2 reaction mechanism. So what is the order of SN2 reaction? It is primary, then secondary, then tertiary. See, first if such a question if they are asking, you should first identify whether the compound is a primary, secondary or tertiary. See, let me take the first compound here. So we know that it is which one, primary or secondary? It is a secondary compound because halogen atom next carbon attached with 2 alkyl groups. So we can say it is a tertiary, and here of course it is a tertiary. So when compared with the tertiary and secondary, which is more reactive? SN2, secondary is more reactive. So this particular compound is more reactive when compared with the next one. Okay, now this is also same type of question, but they are asking SN1 mechanism. What is the order of SN1? This is actually tertiary, then secondary, then primary, then methyl halide. So they are asking the first one. It is what is whether it is primary or secondary. Here chlorine is attached. This carbon is attached only 1 carbon atom, so it is a primary compound. What about this one? This is actually 2 alkyl group is attached, so it is a secondary group. So which is more preferring towards SN1 reaction? The second compound is preferring towards SN1 reaction. So this is the order. How you will write the answer? First you have to write the order. So the order of the reactivity is tertiary, secondary, primary. Since compound 1 is primary and the second one is secondary, so secondary is more preferring towards SN1 reaction when compared with the first one. This is how you have to write the answer. Similarly, same type of question, this already we discussed, this will undergo SN2 reaction. Now coming to this one, this is also same type, we have to identify secondary, primary. What about this? This is actually secondary structure, this is primary structure which is undergoing SN2 reaction. SN2 is actually, primary is undergoing more towards SN2 reaction. This is primary, so primary, this one, this is the answer. What about this? This is tertiary. This is actually secondary and SN1 they are asking, so tertiary is preferring more towards SN1 reaction. This actually they have given some IUPAC name. So in that case what we have to do? We have to draw the structure. 1-bromobutane. Butane they asked butane, CH3, CH2, 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 Br. So 1 bromine, 1 bromobutane. Second case 2 bromobutane, CH3, CH2, CH, here Br, second position CH3. So here this is actually which one? This is secondary carbon, this is the primary haloalkanes. What happened? They are asking SN1. So which is more preferring? Secondary is preferring more towards SN1. So this compound is preferring SN1. Same type of question, this is primary, this is actually secondary, SN1 asking, so which is more preferring? Primary is asking more SN2. Out of SN1, SN2, which will occurs with the inversion? Inversion will happening both SN1 and SN2. So SN1, SN2 both inversion is happening, but racemization is only SN1 reaction mechanism. This is a typical differentiation between SN1 and SN2. You can take a screenshot of this one. So it is a two-step process, I already told, and this is a single step process. Here carbocation formation, but here there is no carbocation formation. This is first order reaction, this is second order kinetics, and the order of reactivity tertiary, secondary, primary, primary, secondary, tertiary, and it is optically inactive because racemic mixture, this is something very very important. Racemic mixture, these are actually optically inactive, but here only inversion of the reaction, inversion of the configuration. And then there is a one example also you have to write, you will get full mark. Okay, this is also same SN2, they are asking SN2, this is secondary, this is primary, SN2 will prefer primary. Racemization occurs in SN1 reaction. What is the reason why? Because both front attack and back attack is possible. So if it is through front attack, there is a possibility of retention. If it is through the back attack, there is a possibility of inversion. So both equimolar composition, that is called a racemic mixture, it is optically inactive compound. So hope it's that clear. So these are the important questions you can expect from chapter haloalkanes, haloarenes under SN1 SN2 reaction mechanism. If you have any doubts, please comment on the session. Thank you. Subscribe my channel. Thank you so much.